In this lecture, we're going to explore the C++ execution model and show you a simplified version of the memory model of your C++ program. Here is how our program looks. It is a simple program. In our main function, it is going to call a simple function that is going to add two numbers. We have seen a program like this before. And when we compile it, it's going to be turned into a binary. This black icon here represents the binary executable, and it is not in the format that you can read with your eyes. If we come back here to what we were doing in the last lecture, we can see our Rooster executable binary here. If we try to open it here, you're going to see that Visual Studio Code is going to say the file is not displayed in the editor because it is either binary or uses an unsupported text encoding. So it says, I can't really say this because it's binary. And it says, do you want to open it anyway? If I try to open it, it's going to be just some gibberish. Because this is binary, it is meant to be read by programs. It is not meant to be by IDEs or text editors like Visual Studio Code. So this is the binary file we have here. I tried to put a simplified version of this program to represent binary so that we can follow it up, but it is not in a form that is readable by any human out there, unless you are a machine. So why is it in binary? Because binary format is easily understandable by your CPU. And we're going to see how your program is loaded in memory and executed statement by statement by the CPU so that you can really understand this. So here is a representation of your program. Here we have our hard drive and we have the program sitting somewhere on our hard drive in binary format, and it's waiting to be run by you by double-clicking on it or opening it in the terminal. And on the left here, we see a representation of the memory of our computer. And when I say memory, I mean random access memory. I don't mean memory on your hard drive. This should be really clear. This is the random access memory of your computer that is running your programs very fast. So when you double click on our program, or if we open it in the terminal, the binary file is going to be loaded up in memory. And you see it in red here. This is a representation of that. And it is ready to be run by the CPU. By the time the CPU sees in the memory location, it's going to know I have a program to run. And the CPU is going to start running it statement by statement. It is going to start by the top. So it's going to see that it needs to allocate space to store our integer A. It's going to allocate to that somewhere on the memory. In yellow here, you see A. And it's going to see that it should store in a value of 10, and it's going to do that. You can see that here. It's going to go to the next statement, and the next statement tells it to allocate space for a value B, and it's going to store in a 5. It's going to go to the next statement. It's a variable called C. It's going to allocate space for it, but we didn't specify a value for C. So what it's going to do is store in some junk value. The value in there is really unspecified at the moment. It's going to jump to the next statement, and what it's going to do is print some things on the console, and it is going to do that. It's going to jump to the next statement, and it is going to print statement 2, and here it is going to notice that it is going to call a function. I don't know if you have noticed, but the CPU has allocated a special memory location for our function. The function doesn't live with our code here or anywhere near the variables that we have here. There might be a huge chunk of memory between these 2 or 3 things. So the CPU knows that it is going to jump to another location. It's going to ask itself, if I jump to that location to run this function, how am I going to come back? And the CPU is smart enough to store the return address. And that's what it's going to do. It's going to say, if I go to that function, I want to come back to the address 6 and run whatever is after this address. So it's going to store 6 in CPU memory, and it's going to jump to the function. It's going to take the first parameter as A and the second parameter as B. So A is 10. The parameter 1 is going to be 10. It's going to take parameter 2. It's going to be 5 because it is B here, and in B we have a 5. And it is going to jump to the next statement in the function, and it is going to add up parameter 1 and parameter 2. After it adds those things up, it's going to return the result to C. We can see that here. Okay, that's what the CPU is going to do. It's going to put the result in C, and the result is a 15. So we're going to write that in there. And now that the function is really done, it's going to come back to its address, and it is going to jump to the next statement after that. It is going to print 3. Statement 3, it is going to jump to the next line and print statement 4. It's going to do that. And by this time, we have reached the end of our program, and it is going to be popped off the memory, and your program is basically going to end. This is how your program is executed by your CPU. And why am I showing you this? Because it is really good to have an idea of how memory is allocated and used by your program. Another good reason is that some C++ features require you to have an understanding of a memory model like this to understand how they work. For example, you have seen that to call this function, the program had to jump from address 6 to 30. And this is really heavy, especially if you are running a simple function like we are doing here to add 2 numbers. So the CPU can realize that and optimize this call to the function to an inline function and add these 2 numbers up right here at address 6 without jumping to this address here. And this may come in handy, and you need an understanding of this memory model to really understand these features. This is just one example I am giving you. You are going to reuse this model a lot in your career as a C++ developer, and I thought it was a really good idea for you to understand it firsthand. This is really all I had to share in this lecture. I hope you found it interesting. In the next one, we're going to try and understand the difference between 3 key components of the C++ programming language. Go ahead and finish up here and meet me there.